Hey everyone, it's Miss List, and we are back with 7.3, which introduces something to us called the reaction quotient and the equilibrium constant. The reaction quotient is given the symbol capital Q, and the equilibrium constant is given the symbol capital K. We can write the reaction quotient or equilibrium equation, also known as an expression, in terms of concentrations, aka molarities, if we are using a system of solutions, or if we're dealing with gases, we can write these using pressures. These expressions come from taking the products divided by the reactants, with each substance being raised to its respective coefficient from the balanced chemical equation. So if I was asked to write an equilibrium expression for this pretend reaction that's A plus B goes to C plus D, we are going to put our products on the top, its products, and divided by the reactants on the bottom. And each of them are going to be raised to their respective coefficients. So this lowercase a that's here would represent the coefficient that becomes the power in this equation. And lowercase b would become the exponent for b, and so forth. One thing to keep in mind when we write equilibrium or reaction quotient expressions is that solids and liquids are not included in the equilibrium expression. We can only include in our equilibrium expression things that are aqueous or things that are in gas phase. The reason solids and liquids cannot be used in equilibrium is because their concentrations do not change with the volume. And so that's an important thing to remember. We can only write equilibrium expressions when we have things that are aqueous or gas phase. The other thing that I want to note is what is the difference between K and Q? You might look and notice that they're essentially the same equation. Q equals products over reactants. The difference is we only use K for when equilibrium has been established. We use Q when we are not at equilibrium. And that's just a little distinction that will become important in later sections when we look at things that are approaching equilibrium or moving away from equilibrium. But for right now, just knowing that K and Q are essentially the same equation should be enough to get us through this section. So we have some example problems where they're asking us to write the equilibrium expression, and we want to think of that as the equilibrium equation. And so let's just practice this. On letter A, I have my products, and this is a net ionic equation, so they've already canceled out the spectator ions. I always want to put products, so copper raised to its coefficient, products, my other product is lead. Lead has no coefficient, divided by my reactants. So I have copper that has a +2 charge, and it is raised to a coefficient of 2. And then we have lead that has a charge of +2. So this is likely a redox equation because of the change in oxidation numbers. But we can also write this as an equilibrium because we see the reversible arrow. So products, copper 1 and lead 4, raised to their coefficients. Products over reactants, copper 2 and lead 2 are my reactants. So this would be a correctly written equilibrium expression for this reaction. Our next example involves things that are gas phase. So sometimes when we do gas phase, instead of using concentration, which we represent with brackets, that means concentration or molarity, because this is a gas phase reaction, I'm going to actually represent this as pressure. So my product is NH3, and that's going to be raised to the second power. products over reactants, pressure of N2. N2 has no coefficient times the pressure of H2, and H2 has a coefficient of 3, so that's going to be the third power. The next example we have to be careful of, and the reason we have to be careful of is because it contains solids. And one thing to note is that when a reaction contains solid particles, we do not include them in our equilibrium expression. That's because they're quantities. Remember, it's solids and pure liquids that do not get included. So if I was going to write this equilibrium expression, I would omit the iron solid. So it's just going to be H2O. And I'm going to omit the iron oxide. Neither H2O or H2 have coefficients, so that is a correctly written equilibrium expression. Also, just so that we are reviewing, you can also write these, since they're in gas phase, as pressures. So that would be like pressure of H2O over pressure of H. Neither one of them, like I mentioned, have coefficients, so we don't need to necessarily raise them to any power. So conclusions from this section. 1, we write an equilibrium expression / reaction quotient for a chemical reaction. If it's at equilibrium, I use K. If it's not at equilibrium, I use Q. But they're essentially the same expression, products over the reactants. And we can only write these for things that are aqueous and things that are gas phase. We cannot include solids and liquids in our equilibrium expression. In our next section, we will start learning how to use this equation to do calculations, but 7.3 is just introducing this expression or equation to us so that we can understand how to set it up. I'll see you guys next time.